in the science paper? Any doubt in the science paper? Can I have your videos on, please?
Just give me a minute now. I'm just going through the science paper.
Okay, Ibrahim. Okay, tell me your videos, both of you. Yes, teacher, what is science? Get your books. I'm reading maybe. Emma, can you hear? It is for biology.
Ma'am, can you repeat what you just said?
Yes, Emma. Turn on your video, Emma.
Let me just try. The Wi-Fi is really bad today.
And are there any doubts in the science test, Emma?
Ma'am,
Yes,
ma'am, this in this question in the ticks from is the place where I lost marks, right, ma'am? In the take the correct statements. In the following statements, take the it says in the one of the ones that accept a mixture of milk and water can be separated by the process of decantation.
Okay.
Ma'am, when I was checking Google for the test, because I was not understanding this, I think I came up across the thing saying yes, it can because milk has lesser density than water. I will just share.
Okay.
Ma'am,
Yes, Abraham.
another thing is, ma'am, in Google they are saying, if you even search in Google, they are saying that about there it cannot be separated by decantation. But if you scroll a little down and you go to web and you click on the things, they are saying yes, they can, a mixture of milk can be separated by sedimentation and decantation. On Google, they
Okay.
also mention it that it cannot be effectively separated, but I think you can separate it by decantation.
Okay, so can you separate it by only decantation? Because I was reading it too, I checked it out too, and it said that by only decantation you cannot separate because it is like for the um, materials or for the solutions with different density. Okay, so one will form a layer above and one will form a layer below, and then you can separate. But milk and water, when you put them together and you mix them, they just get mixed together. Okay, they do not form a separate layer, but they just get mixed together. Okay, so it's like I don't think it's quite possible to separate them by decantation alone. Okay, by only decantation, I don't think it is possible to do that.
But you said in the question is that milk and mixture of milk and water can be separated by process or decantation. It doesn't say only by the process. It means it's a process that can be used to separate milk and water.
It is a process, yes, to
It,
separate,
it,
but this process is not for like milk and water. Okay, milk and water we cannot really separate by decantation, Abraham. Okay, try it out at home and see if you want to. Okay, with a little milk and water. Try decantation at home and also check out. Okay, if you are actually able to do that, but because they are both miscible means that they get mixed together, you cannot really separate them by just decantation, by the decantation process. Okay. Anything else?
okay, ma'am. And ma'am,
Hmm.
next, ma'am, I have this question. Hulls could be separated from grains by winnowing.
Mm-hmm. That is right.
Ma'am, this question I thought about it, ma'am, and still I marked it as false is
Mm-hmm. Because
because, ma'am, that husk when you husk is the chaff is like the thing on the grain, right, ma'am?
yeah, the chaff that is very lightweight.
But ma'am, the thing is, if you because they're so bound because they bounded together, like even when my birds eat food or something, they don't like because they're eating grains, they have to first take out the chaff, and the chaff is not taken by out by winnowing. It has to be broken out, and then only you get to eat the grain. So
Mm-hmm.
winnowing doesn't explain how the chaff will be broken out because they are bounded together. The chaff and both the grain will fall down.
The chaff is separated already before they do winnowing. Okay, before winnowing, it is a thing to like separate the chaff. Okay, they are like tied together for like it is made loose. The chaff is made loose first. Okay, the husk is made loose, and then it is like shaken in the air. Okay, so that it falls off and the grains are left behind. Okay, the husk falls off. It is like
How is
first.
how is anybody supposed to know in a one line question whether the chaff is still on the thing, on the grains, or it's in a mixture with the grains? Ma'am, that's difficult to know because it's not mentioned anywhere in the question.
So next time it comes as such as this, you just have to make like you'll assume that it is already um loose. Okay, it's not tied together along with the grains, the chaff. Okay, this happens in winnowing itself. Like it is a part of winnowing process that before they do the winnowing, they loosen up the chaff and then small portions of it, portions of husk or chaff is taken and then it is shaken so that it falls off and you will have the grains.
Ma'am, but I don't think this is mentioned anywhere in the book about the. In the book, they just say the method of separation both components from by windows winnowing.
Mm-hmm.
But ma'am, a husk when it's on the grains, then
So
how
when
can
it is shaken in the presence of air, if the husk is on the grains, and you shake it in the presence of air, the husk will fall down and the grains will be left at the bottom. Like
Okay,
this
ma'am.
is the container, grains are there, and the husk is there on top of it. Okay. Then when it is shaken in the air, it falls off with the air, and the grains are still there in the plate or something that is that holds it while we do winnowing. Okay. So these are the this is the thing, Abraham, that you have to keep in mind that in winnowing they always they don't like bundle it and do it winnowing, but in the winnowing process itself they loosen the chaff, they loosen the husk, and then they do winnowing so that it can fall off. Okay, all right, okay,
Ma'am,
all
but you
right.
never told us this part about that they loosen the grains first.
Okay, I don't know how we missed on it, but like now I'm telling you, so remember, okay?
Okay, ma'am.
Okay. Now, did we do in text questions 12.2? Not yet, right?
Sure.
Let's do 12.2 and then we have the last topic that is left, that is food storage. 12.2, take the correct statement and cross the wrong ones. Microorganisms are both our friend and foes. True or false, Emma? Emma, the first one.
Ma'am, the answer is the it's
Abraham, the first one.
Yes, ma'am. Microorganisms are both our friends and foes. Correct. So does lactobacillus bacteria. Correct.
Mm-hmm. Good. And the third one. Okay, Emma.
yes, ma'am.
Third and fourth one.
Yes, ma'am.
Microorganisms aren't used in baking industry. True or false?
Yes, ma'am. The answer for the first one is false, and the answer for the second one is true.
No, Emma. The third and fourth.
Yes, ma'am. So the third one, microorganisms aren't usually the baking industry is false, and then the antibiotic medicines are made for antibiotic medicines are made up of fungi and bacteria is true.
Okay. Yes, Emma. All right. Microorganisms borne diseases are known as Abraham. Microorganism-borne diseases are known as Emma,
I don't know. I don't remember.
okay. Abraham, infectious diseases, or even right, communicable diseases. Now, chickenpox is taught by dash in the world,
Vaccinations.
vaccinations. Yeast dash fast in wet floor,
Rose.
grows. Female dash dengue and female dash malaria are the carriers of diseases.
Mosquitoes.
Yes, but what is the name of mosquitoes? Aedes mosquito, and
And
Anopheles
Anopheles.
mosquito. Okay. If food is not stored properly, then it gets dash in it.
Bacteria in it.
Bacteria. Yes.
Bacteria.
Now, um, write three benefits and three harms of virus in the following table. Abraham, can you give me two benefits and one harm of bacteria, of virus?
One benefit is that viruses make our immune system stronger. But the harm is if it doesn't make our immune system, is that it can take a toll on our lives and even potentially kill us.
Benefits is one of the benefits is immunity. Harm is illness.
Then another harm is that it it can pose a threat to our lives.
Okay, threat to life. Okay, Emma, can you give me two benefits and one more harm?
A benefit of a virus is that then after you get a certain virus, doctors and other scientists can do research to see like how to how it's caused and how to make an antidote for it, like the coronavirus.
Medicine or research? And any other benefit, Emma?
And the harm is that can rapidly spread throughout the body.
Disease causes diseases.
Yes, ma'am.
Okay, alright. Now, next topic is food storage. Turn on your videos, both of you. When mango is kept for a few days, it gets rotten, but mango pickle does not get rotten soon. In the same way, green chili gets damaged, but dry red chili powder is stored for months. Why this happens? Food items get rotten because microorganisms they start increasing in them. Now there are some ways to stop their multiplication so that the items are stored safe for longer duration. Now, if we just keep some things like that only, it can cause it may rot. Those things may rot due to the microorganisms. That is why things are preserved. Okay, there are two things: either they are stored in such a way that microorganisms do not multiply fast enough and they do not rot quickly, or they are preserved in the form of sauces, pickles, jams, etc. Okay, we'll see some methods how we can store food longer, how we can store food longer for a long period of time. First method is drying. This is the oldest way to secure food items. This is people have been using it since a long time. Drying up is the cheapest way to secure grains, fruits, spices, and vegetables. Microorganisms they multiply in moisture, and there are fewer chances of microorganisms to multiply in dried grains. When the grains are dried, when all these items are dried, it will not easily get spoiled because microorganisms will not multiply in them because drying soaks up or absorbs all the moisture. Okay, or like all the moisture is taken away when you dry something, when you dry certain grains, fruits, spices, and vegetables, it removes all the moisture, the sun removes all the moisture, and then the microorganisms cannot multiply in it. So we can use them for a long period of time. Papad and badiya are protected by drying them in sunlight. Okay. These two things are dried in sunlight. Also, like chilies are dried in sunlight. Okay, some fruits are also dried in sunlight to make them moisture free and so that we can use them for a long period of time. Okay, then we have the use of chemical products. Growth of microorganisms is also stopped by salt and oil. Therefore, this is known as preservation. Okay, preservation, or you can use an alternative heading for like salt and oil, such as use of preservatives. And using chemical products, you can use the heading use of chemical products. What are the chemical preservatives? Sodium beta bisulfate and sodium benzoate. Okay, these are the chemical products, chemical substances that are used, while as the natural preservatives are salt and oil. Okay, therefore, this is known as preservation. Salt and oil are used in pickle in the form of preservatives. If pickle is also there, okay, we fill oil in it, we submerge the pickle in oil and then we store it. Why? Because oil cuts off the air supply, okay, cuts off the air supply in the this thing, food item. Also, the moisture is not present. Okay, so microorganisms cannot grow when something is kept immersed in oil. Okay, so it doesn't rot, but it is preserved. Also, salt acts as a preservative in the same way. Okay, now salt and oil are used as natural preservatives, whereas sodium beta bisulfate and benzoate are used as chemical preservatives. They're used in jam, jelly, juices, etc. Salt is used as preservative in meat and fish since a long time. If like we caught a fish, we just clean it, cut it, and then we are not cooking it at that time only. So we put salt nicely and then we store it in the freezer, right? Even meat also, we put salt nicely and we store it in the freezer. Why? Because it acts as a preservative. It will not spoil. Okay. To stop with growth of microorganisms, meat and fish are covered with dried salt. Salt is also used as preservative in mango, gooseberry, tamarind, etc. Okay, all of these also use the salt as a preservative. Sugar is also a preservative. Okay, in sweet things we use sugar as preservatives such as jam, sauce, juice. Okay, we use sugar as a preservative. Microorganisms don't develop in vinegar. So vinegar is also a preservative that is used in many items. Okay, understood? In salads and all, onions and all, we use vinegar. Okay, put vinegar and salt, and then we store them. Morning to evening, we store it. Okay, people store it by adding these things so that the vegetables and whatever is present in the salad will not get spoiled. Okay, now next is by boiling or cooling. If milk is boiled, then it does not decay. Many microorganisms present in milk are killed in the process of boiling. Therefore, food is prepared at high temperature to stop the growth of microorganisms. One more important condition is that we give it extreme temperature. Okay, treat the food with extreme temperature. If you like heat it at very high temperature, boil it, or if you cool it or freeze it, then also like microorganisms will not grow in the food. Okay, low temperature does not lead fungi and bacteria to grow. Therefore, food items are kept in fridge and in ice box. Some of them are fruits, vegetables, fish, milk, etc. Boiling kills the microorganisms, and then when we store them in freezer and all in the fridge, freezer, that is very low temperatures. So it will lead to like their preservation, it will lead to their protection from microorganisms because microorganisms do not grow in extreme heat or extreme cold. Pasteurized milk can be used directly without boiling. Pasteurized milk is the milk that we are receiving from the dairy, okay, which is already processed, means that before the packaging of the milk or before it is sold to us, they already heat it and then cool it down and then they pack it. Okay, they boil it and then they cool it and then they pack it and then it is sold to us. So we can also use it directly. This is because for pasteurization, the milk is boiled at 70 degrees for 50 to 30 seconds. Then this boiled milk is chilled for storage. By this, the growth of microorganisms is stopped. Okay, so this is already done in the factory, in the dairy. Okay, and then it is sold to us. The last one is seal packing. Food items are boiled and seal packed in a way that air and moisture do not reach them. If you've seen those like silver color packaging, that's silver from inside, and it's like fully tightly packed that moisture cannot reach inside. Okay, and air also cannot reach inside. The food doesn't come in contact with moisture or air, and it remains fresh until it is seal packed. Once you open it, it will become a little soggy. It will lose its crunch and all. Okay. Yes, Abraham, because it reacts with the moisture that is present in the air once it is opened if you do not store it properly. Yes.
Okay, ma'am.
Okay. Food items are boiled and sealed packed in such a way that air and moisture do not reach them. In this way, microorganisms present in these items cannot breathe easily and their growth is stopped. Okay. They do not grow. We'll stop here for today. Tomorrow we will do 12.3 and the end of chapter questions. Okay, 2 minutes break for y'all and then we'll start with maths.
Okay.
Okay, let's begin with maths. Hello Joshua, good morning.
Hi, ma'am. Good morning, ma'am.
Good morning. Abraham and Emma, turn on your videos. Okay, so Joshua, you didn't join the Friday's class last Friday. Did you watch it on YouTube?
No, ma'am, I didn't get the chance, ma'am.
Okay. Can you do it today?
Okay, ma'am.
Okay. Watch it today. I started with a new lesson that is the 8th chapter, percentage. Okay. And that was the basic class. Like we covered all the basics about percentage. Okay. So watch it. And then if there are any doubts, you ask me. Okay. Okay. Okay, Abraham and Emma, any doubt in the maths test?
No, ma'am.
Okay. Abraham, any doubts in the maths test? Can you all turn on your videos? Emma, turn on your video. Abraham, you too.
Yes, ma'am. Why did I lose 6 marks, ma'am?
Why did you?
Maybe ma'am, just 1 minute. I'm opening it.
Mm-hmm.
Ma'am, why did I lose? What do you call that? Ma'am, can you explain the sums of third question 1 and 2, ma'am? It's because, ma'am,
Which questions, Abraham?
1 and 2.
Question 1 and 2.
Yeah, ma'am. Because,
You
ma'am,
didn't lose. Okay.
sixth question 1 and 2.
Sixth question 1 and 2. Okay. Your second one was correct, Abraham.
Ma'am, just the sign. My question with the sign was, ma'am, you said minus minus. Ma'am, minus minus is plus. No, so shouldn't plus come plus 17? See?
Minus minus is plus, Abraham. That is why when you are having minus 12c and minus 5c, that is why, because minus minus is plus, it will be added and it becomes 17c. But remember, I told you that when we are doing addition and all, we put the sign of the bigger number here. Okay, the sign of the bigger number will come in the answer. All right, this was like the thing that was there at the sign of the bigger number we put in the answer. Also in this one, minus 12c plus 2c minus c. Okay, this was the rest portion was correct of yours, but this last portion, first do these two. First do these two. Minus 12c plus 12c. Minus plus is minus. So 12 minus 2, 10. Sign of the bigger number. So minus 10c minus c. Now minus minus is there again. Minus minus is plus. 10c plus c, 11c. And 10c is negative. Because 10c is negative, it has a minus sign. I will put a minus sign here also. And it becomes minus 11. Okay.
Okay, ma'am. Okay, ma'am. I didn't understand that part.
Mm-hmm. Okay. So don't get confused next time. Next time, solve it according to the signs and then just put the sign of the bigger number. Okay.
Yes, ma'am.
Any other questions?
No.
Okay.
Yes, ma'am.
Yes, Abraham.
Ma'am, in the sixth question, the first
Six,
part, ma'am, why did I get it wrong? 12x
sixth,
minus 60x square. 20x.
sixth question. Okay. 1 second. Let me just see your
Ma'am, is because x is not equal to x square. And what is the answer?
Mm-hmm. 1 second, Abraham. Let me open the paper.
Ma'am, you've written 19 minus 40x, 14x.
No, I think I've written
See, 9 minus 14x.
9 minus 14x. Yes. Just a
Ma'am,
second.
what happens to that x square, ma'am? Because at the end, there's an x square. Then x square and x don't.
Sixth question, first part, Abraham, right?
Yes, ma'am.
There is not any x square in that, Abraham. Check the question once again. There is no x.
Yes, ma'am. There is not any x square.
Yes. See, we have question was 7 minus 2. 7 minus 2. 4x minus 1 minus 3x. Okay. This was your question.
Good. The thing I did wrong was that I added an x square, right?
Yes, Abraham. That, and also one more thing, Abraham. We first solve the inside of the bracket. Okay. We first solve the inside of the bracket. That is why I wrote it in the form of correction in your paper. Okay. In your paper.
Ma'am, I was not able to solve the inside of the bracket is because those are minus sign.
Okay, because there was a minus sign.
Minus sign. And normally when it's a minus sign, it means that first you solve the inside of the bracket, which is not possible because we don't know the value of x.
No, you don't have to find the value of x, Abraham, but
Ma'am,
do the.
I know, ma'am, do the simplification, ma'am. Ma'am, when
Mhm.
you solve the inside, 4x minus inside of the bracket into inside of the bracket doesn't actually work. When you put a minus sign in front of a bracket, it means that after you solve the bracket, you're going to subtract that number from 4x.
Abraham, because minus minus sign is there. Okay, because minus minus sign is there, and 4x is still outside of 1 minus 3x. It means that it will be evaluated with this and this. Okay,
Ma'am, you never said anything like that, ma'am.
and also because minus minus signs will be evaluated, it will become 4x minus minus is plus, and then there is 3x. So that is why 7x, then minus 1 comes as it is. Okay, minus 1 comes. Okay, this will not be multiplied really because the minus sign is there in between 4x and 4x and 1 minus 3x. The minus sign is there in between. So multiplication will not happen here. But because minus sign is there, we're gonna add 4x and 3x and minus 1 as it is. It's gonna come here. Minus 1 as it is will come here. Now what you will do is that you will multiply this 2 with 7x, okay, and 2 with 1, okay, because we are solving the inside of the bracket first. 7 minus 7 2s are 14, x, 2 1s are 2, minus minus plus 2, okay. Now we are going to do these two together. So 7 plus 2 you're taking as it is here, and minus 14x you're gonna keep there. So 7 plus 2, 9 minus 14x. Okay.
Okay, ma'am. Thank you.
Okay. Did you understand, Abraham?
Yes, ma'am.
Okay. So always solve the brackets first. Okay. And then we move on to the external number. Okay. Anything else?
Ma'am,
Mm-hmm.
the A to subtraction, ma'am. So basic, I'm understood now. So even in subtraction and addition, you will still follow the same rules, right? But
Yes.
only in subtraction, the sign will be minus ahead. Can you
Hmm.
just show me a subtraction sum?
Show you a subtraction sum.
Ma'am, because then I'm not understanding the difference.
Okay. Yes, Abraham, we can do that. Let's do the first one.
Ma'am, second question of fourth.
Second question
A
of
square
course.
plus 3b. Ma'am,
2b
fourth.
square plus 3b. Okay. Okay. 2a square plus 3b. We have 2a square plus 3b
Ma'am,
minus
minus 2 square.
a square minus 2b. You can do it with column. You can do it by taking common. I'm doing by taking common. A common and B common. 2a
Ma'am,
square.
ma'am,
Yes.
ma'am, can you show me by column method, ma'am? Because I
Okay.
did by column method, I'm not understanding.
Alright, Abraham. By column method, 2a square plus 3b a square plus 2b. Because plus signs are there, 3b plus 2b, 5b plus. Now you have to subtract 2a square minus a square. How much? A square. Why? What is the meaning of 2a square? If you spread out 2a square, it means that you are having an a square and an a square. Okay, that is the meaning of 2a square. Try to understand this. Okay, 2a square means that you are having an a square and a square. The question says that out of this 2a square, you take out an a square. You take out an a square. So what will you be left with? You will be left with this another a square only. This you will have. Okay. If you 2a square means that I have a square and a square. Okay, two a squares I'm having. One a square I have to minus, so what will I have? Only one a square, right? So that is why I have my answer a square plus 5b. Okay. If you check it out in the grouping method, what I've done is directly I've grouped 2a square minus a square, same way a square, and 3b plus 2b, I have 5b. So a square plus 5b. Okay. Okay. Shall we move to the 8th chapter? Anything else?
No, ma'am.
Okay. Emma, this was your also, right? Or yours for another question that got wrong. Did you understand? Yes, Emma. Yours was this one, Emma, right? AB, A square minus B square.
Yes, ma'am, I can see this one.
Yes. So, Emma, you have to multiply this with this and this with this. So it becomes, when you do A into A square, it becomes A cube B minus A B. Now 1B you have here and 2B's you have here. So A, B, Q. Okay, Emma?
Yes, ma'am.
Alright. Now, okay, Joshua, what is a percentage?
I don't really know, ma'am.
You don't
But then,
really know.
but then in percentage, you can let's say in a maths test, you can get 50 percentage in the maths test.
Yes, you can get 50 percentage in a maths test. Okay, that is true. Percentage is basically, Abraham, that with the base 100,
I'm Abraham.
how
He's
much? Oh, sorry, yes. Joshua, percentage is basically when you have 100 as a base, okay? And like when you're having 100 as a base, you will express it in that form, okay? By keeping 100 as a base, you will express it in the form of percent, okay? You'll express it in the form of percent, or you can say that a fraction whose denominator is 100 is called percent. Okay, denominator, the base is 100, is called the percent. Okay, now yesterday, like in the Friday's class, I taught how to compare two fractions with different denominators and then how to convert fractions into percentage. Yes?
I have a question, ma'am.
Yes, Abraham.
So, ma'am, um, My question is, ma'am,
Mhm.
so basically percentages is the method of comparing when two fractions are equal to upon 100, right?
When
When
two
two fractions are the
fractions,
same denominator, which is 100.
which is 100, yes, we can say that. Okay. When fractions have the denominators as 100, we can call that percent. Okay. And percentage is a method for calculating it. Okay. It is a method for calculating it. Now, Joshua, for a quick recap at what how to calculate percentage when you have fraction. Suppose I have a fraction, random fraction 3 by 5, and I have to convert it into percent. Okay, I have to convert this fraction into percent. Abraham, what I will do?
When you will multiply by 100, which is way easier, ma'am.
Yes. So Joshua multiply by 100. Okay, 5 ones are 5 twos are 0. 20 into 3,
60%.
60. 60%. Okay. This is how we convert any fraction into percent, Joshua. We can multiply it by 100. Okay. You need to see the Friday's lecture, Joshua. Okay. Please see the Friday's lecture today. Now, how to calculate the percent into fraction? Okay. How to calculate the percent into fraction? Did I teach this, Abraham? Not yet, right?
Ma'am, isn't it easy?
Suppose I'm having 45%.
Ma'am, because first you will see upon 100 and then after from upon 100 you will simplify it, right, ma'am?
Yes, Abraham, correct. 45. As soon as you see this written like this, 45, this is a percent symbol. This is the percent symbol. As soon as you see this percent symbol, it means that it will be divided by 100. Okay. So 45 divided by 100. Now you can simplify it. Okay. You can simplify it by 5. 5 nines are 5 twos are and 0. 9 upon 20
Ma'am,
is
I
the
have a doubt.
yes.
If I'm not able to simplify it, can I and the question asks me, can I just write it as a normal, just write it as it is?
Yes, Abraham. If you are not able to simplify it, it will be 45 upon 100. If nothing is cutting, if you are not able to simplify, it will be as it is, okay, divided by 100. Okay. Understood, Joshua? The difference? Understood? When we are converting a fraction into percent, when we are converting a fraction into percent, we will multiply by 100. Okay. Multiply by 100. When we are converting a percentage into fraction, we will divide it by 100. Okay. Easy, Joshua. This is easy.
Yes, ma'am.
Okay. Write this down. Yes, write this down.
May I go to the restroom?
Yes, Emma.
Done, ma'am.
Then copying. Okay. Okay, so I'm going to give you some questions to try out. Okay. First, we'll see if you're having, we're doing percent into fraction. What if we have a mini fraction
Can
or
we Ma'am, can you give us some questions, ma'am? Because last time I don't think you gave us enough.
Okay. Percent to fraction we are doing. Let's try this out. 15%. And 35%. Vishwa, what is the fraction of the first one? What's the answer for the first one?
Ma'am, I'm trying to get it out.
How do you, what?
You get the number. I get the answer.
I just thought how you get the answer. You are going from a percentage to a fraction. So what will you do?
First, you have to multiply by 100.
No. That is for when we are going from a fraction to percentage. When we are going from fraction to percentage, we will multiply by 100.
You have to
When
divide.
you
You have to
yes,
divide by 100.
yes, we'll divide by 100. After dividing by 100, what will you get in the fraction? How will you write this? First, tell me, how will you write this?
Like, I didn't get the question, ma'am.
15%. How will you write it? You said like divide by 100, right? So how are you going to write it down?
I'll just write 15 divided by 100.
Like this? Will you write it like this?
Yeah.
Okay. And then what will you do?
Then I'll simplify it.
Okay. Tell me how will you simplify? With what will you simplify 15 and 100?
Let me see. I think 5.
5. Okay. Okay, so 15 will be what?
3.
3. And 100 will be?
100 will be 20.
20. What
Then you
will
get
be your
3 upon
fraction?
20. You get 3 upon 20.
3 and 20. Good. Good, Joshua. This is how you convert percent to fraction by dividing by 100 and simplifying it. Okay. Yes, Abraham, second one.
Ma'am, it's it's 7 upon 20.
7 upon 20. Correct.
Ma'am,
Yes.
when you're doing it by 5, ma'am, 20 will always be the denominator, and you just have to see which one multiply by what is equal to, like, you have to just basically divide 35 by 5, which is 7.
Yes, Abraham, that is right. Let's level this up a bit. Okay. Joshua, have you written? We will increase the level. Suppose I'm having a mixed fraction. Now suppose I'm having a mixed fraction. 16 whole number 2 by 3%. And I have to convert this into a fraction. What I will do, I have it like this. First, you need to do what is that you have to convert this into a normal fraction, okay, improper fraction. 16 into 3, 48 plus 2, 50. So 50 divided by 3. 50 divided by 3. Now, always when we are converting from percent to fraction, we need to divide by 100. So 50 divided by 3 divided by 100. Now, how I told you that this will be solved is when you have
Reciprocal.
divide reciprocal. Okay, so 50 divided by 3 into 100. Okay.
Yes, ma'am.
One second. This would be your 1000 divided by 3, 3 ones are. Or you can just do, your book has done like this, 50 into 3, 1 by 100. 1 by 100, okay? Why 100 they have taken as a denominator? Why 1 by 100 is because we need a fraction. Yes, Abraham?
Actually, 1 by 100 also works out, ma'am, if you're doing it by the reciprocal, ma'am. Because 50 upon 3 divided by 100, we don't know that there's a 1 also underneath the 100.
Yes, there is a 1 underneath the 100. Yes, Abraham, that is true. 50 divided by 3, we have 100 divided by 1. Okay, 1 is usually not there, not really there, but let's assume that it is there. So when we are going to solve it, we'll put it in multiplication. So 1 by 100. Okay, it's going to give us the fraction 50 divided by 300. Cancel it.
Ma'am, I have a question. Can I cancel the 50 0 with the 100?
Can you cancel the 50 0 with the 100? Yes, Abraham. You can cancel. 1 upon 6 is the fraction. Okay, 1 upon 6 is the fraction. Okay, Joshua, solve this and tell me. Joshua, solve this and tell me the answer.
Okay, ma'am.
Tell me how you will solve it. 2 by 3 divided by 4 by 6. How will you solve it?
Ma'am,
Mm.
asking me is pretty hard because I didn't really get what you're supposed to do, because in the end you get two different answers.
you didn't really get what you're supposed to do. Okay. Okay.
Ma'am, can I
When
explain
you have
Joshua?
it like this, Joshua, when you divide it. Okay, Abraham, you can explain Joshua.
Joshua, it's basically very easy. Number one, what we have to do is, like ma'am said, we have to do a reciprocal. Reciprocal means is that you convert multiplication into division by taking the fraction and turning it upside down. So 6 comes on top and 4 goes on down. Then what you can do is you can multiply normally and then simplify, which is easier to understand, or you can simplify and then multiply. So you can cancel out 3 with 6, which will give you 1 and 2. Then you can cancel out 2 with 4, which will give you 1 and 2. Now then you multiply 1 and the 2 to get 2 and 2 and the other one and 2 to get 2. So the answer becomes 2 upon 2. Another method is you can also multiply it first. 3 6 are 12, 2 4s are 8. Okay. Say 3 4s are 12 and 2 6 are 12. And then what you can do is, then you can further simplify them by 2.
Okay. And
Okay. Okay, see Joshua, what happens is, good Abraham, 2 by 3, okay, divided by 4 by 6. You have to put this when you're like a fraction divided by a fraction, the bottom fraction, you will take it to the top, okay, you'll take it to the top and it will be reciprocal. Reciprocal means that 6 will come on top and 4 will come on down, will come down. Reciprocal means you turn it upside down. You turn it upside down. Okay. Like 2 upon 4 is there. Suppose 2 upon 4 is there. Reciprocal would be 4 upon 2. Okay. Upside down. Okay. So how we will do it? How we will do it? 2 by 3. Okay, 4 by 6, always the bottom fraction, you reverse it. So put a multiplication sign, 4 by 6 becomes 6 by 4. 4 by 6 becomes 6 by 4. Now what Abraham explained is that, Joshua, can you simplify this right now? 2 by 3 into 5, can you simplify it and tell me if you will get what are you getting?
ma'am, your voice is breaking. Your
Yes.
voice is breaking. I can't seem to hear you properly.
Abraham and Emma, can you all
Ma'am,
hear me
I think your
properly?
network, you're having back. No, ma'am, your voice is breaking too. I think, ma'am, you're having network issues.
I think I'm having network issue. Okay. Now is it better?
Yes, ma'am.
Yes. Joshua, can you simplify 2 by 3 and 6 by 4 and tell me the answer?
Okay, ma'am.
Yes, simplify.
And ma'am, the answer I think is not 2 by 2, ma'am.
Yes, Joshua.
Nothing, ma'am. I'm just thinking.
Okay, Joshua. Can I do 2 ones are 2 and 2 twos are
Ma'am,
4? Yes.
can I do it?
Yes, you can do it. Emma and Abraham. Till then, you guys solve one question.
Okay.
Joshua, you solve this simplification one. Okay. And Abraham and Emma, you guys solve 13 whole number 1 upon 3. Solve this fraction. Find out the answer. Yes, Joshua.
Ma'am, I simplify both problems. 2 by 3, and then I got 1 upon 1, and then I simplified 4 by 2, and I got 3 upon 2. 3 upon 1. Ma'am?
3, 1, 2. Yes, Joshua. And 3, 2, 0. You got 1 upon 1 and 2 by 2. Like this you got, right?
Yes, ma'am.
So what will be the answer, Joshua? 2 1s are 2 and 2 1s are 2. What will be the answer now?
2 by 2?
No. This can be simplified more.
Oh, then you get 1 by 1. 1 upon 1.
1 and 1. When we have 1 in the denominator, it doesn't have any value. So the answer becomes only 1. Okay. 1 by 1 we never write because 1 has no value, but we just write only 1. Okay. 1 by 1 becomes 1. Understood now, Joshua?
Yes.
Understood this type of questions? Okay. I'll send you some questions such as this to practice, Joshua. Okay. Yes, Abraham and Emma, what are you getting?
15 upon 2. 2 upon 15.
2 upon 15. Emma?
I got 2.15.
2 upon 15. Okay. Okay, Joshua, solve this now. First, tell me what will be the improper fraction of 13 1 by 3?
Like?
Like this is like 3 numbers here in this fraction. How will you make it a normal looking fraction? A normal fraction. How will you make it a normal fraction?
I guess it's by doing the same thing we did last time.
What thing?
With wait just a moment.
See, Joshua, when you're having 3 numbers in a fraction, this is known as a mixed fraction. Mixed fraction. Okay, this is known as a mixed fraction. How do you convert it into a normal fraction is, suppose I'm having 13, 1 upon 3. You take 1 and you take the denominator and the number on side and multiply. Okay. So I will do 13 into 3. How much? Emma, how much? 13 into 3. 13 into 3. 39. Okay. This is step 1, Joshua. Step 2 is, Joshua, in 39, I will add the numerator. In 39, I will add the numerator. So 39 plus 1, how much? Numerator is 1. So I have 40. I have 40. Okay. So how will you solve it? How will you solve it? This 13 1 by 3 becomes 40 upon 3. Okay, 40 upon 3. Now we'll do into 1 by 100.
Ma'am, how does it become 40 upon 3?
How does it become 40 upon 3?
3.
This is where I've explained you. Okay. 3 remains as it is, Joshua. Okay. This 3 of the denominator, remains as it is in the fraction. We only change the numerator. How do we change the numerator? We will multiply this 3 with the number on side first. We will multiply this 3 with the number on side and add the top number to it. Add the numerator to it. Okay, whatever product that is after multiplying, whatever you will get, plus the top number in it. That is add the numerator and you'll get this number. Okay, this is your improper fraction. 40 by 3. Now do into 1 by 100 to get your percentage, to get it converted into a fraction. So we can cancel Joshua 0 with 0. Okay, 0 with 0. How are you getting 2 by 15?
Ma'am, because when we do 40 upon 3
Mm-hmm.
into
Okay.
100 upon 1, we cancel the 40 with the 0, then we cancel 4 and 10, which becomes 2 upon
Okay. Yes.
5, and 3 into 5 is 50,
Yes.
and 2 1 is 2.
Yes. 4 and 10 will be cancelled. We'll further simplify. 2 and 3 fives are 50. 2 upon 50. Understood, Joshua?
Yes, 99.9999%.
Are you sure you understood?
99.999%.
Okay. Then I'm going to give you some questions to try out, Joshua. Okay. Conversion questions where you convert mixed fraction into improper, like this thing. See, Joshua, add the side number. Multiply the side number with the denominator and add the top number to it. Okay, that's all you have to do. Suppose I'm having 2, 1 by 2. So this 2 and this 2 we multiply. This 2 and this 2 we multiply. And then add 1 to it. Here you add. After multiplying, you add. So 2 into 2, 4 plus 1, 5 upon 2. This becomes 5 upon 2. Okay. Side number and bottom and side you multiply and then add the above number. That is how you convert. Okay. Understood? Okay. We'll stop here for today. Abraham and Emma try out some questions from exercise 8.1. First and second question. 8.1 first and second. Decimal I will teach you tomorrow. How to convert percent to fraction, decimal percent to fraction. Today we did normal numbers and we did mixed fractions, and tomorrow I'll teach you decimal one. Okay.
Ma'am,
About the decimal. Yes, Abraham.
in decimal, ma'am, you have to divide by 100, right?
In decimal, yes. First you remove the point and then you have to do it into 1 by 100.
Ma'am, I thought that in decimal, ma'am, you have to take the percent and then you have to divide by 100. Suppose like you have 40%, then you take the 40% and then you divide by 100 and then you get the decimal. Like 40
You have
divided by 100 is 0.40.
okay. Abraham, you can suppose you're having like 11.5% and you have to convert it into um, fraction. You can just multiply 11.5 by like 1 by 100. Okay, you can just directly do 11.5 into 1 by 100. Or you can do
I'm
1.5.
multiplying by 1 by 100 is the same as dividing by 100.
Yes. Multiplying Well, 1 by 100 is same as dividing by 100.
Just divided by 100, ma'am. That would be way easier.
Okay. Just divided by 100 works, okay? Alright, so we'll stop here for today and I'll see you guys tomorrow. Okay?
Okay, ma'am. Bye, ma'am. Thank you, ma'am.
Okay. Bye.
Ma'am, thank you, ma'am. See you too, ma'am.